Yes. Good afternoon, dear students. Welcome back to computer science class. So then in the last class we are discussing what is stack, right? What is stack? How to implement the stacks and how it will work, right? Everything we will study in previous class only, right? So let me explain briefly. So what is stack? How it will work? Okay. So stack is a homogeneous data element. Homogeneous means what? Same data element. Right? Homogeneous means what? Same. Right? A stack is a homogeneous. Stack is a order collection of. Stack is a order collection of homogeneous data element where the insertion and deletions takes place at the one end. That is our top end. Okay, that is our top end. So what is stack? The definition of stack is a order collection of homogeneous data element where the insertion and deletions takes place at the one end. That is our top end, right? So it is also called as LIFO. LIFO is nothing but what? Last in, first out, right? Last in, first out. Okay. So, for example, last in, first out means what? So, in your train, you have got confirmed reservation ticket. So your seat number is what? Your seat number is 75 at the last end. After your destinations reach the train, so you will be first out, right? So your last outcome delivery first ನೀವೇ ಕೆಳಗಿರಬೇಕು because your seat number is 75. You are in last. That means you are nearest to door side. You will ಇರ್ತೀರಿ door side ಇರ್ತೀರಿ ನೀವು. Almost door near ಇರ್ತೀರಿ ಹೌದ್ರಿ. So last ಇರ್ತೀರಿ first ಇರ್ತೀರಿ, right? ಒಳಗೆ ಲಾಸ್ಟ್ ನೀವೇ ಏನಾಗಿರ್ತೀರಿ ಫಸ್ಟ್ ನೀವೇ ಔಟ್ ಆಗ್ತೀರಿ, right? So when the train is reach the destinations, right, then you will be first out, right? Train ನೀವು ಹೋಗಲ್ಲಿ ಕೂತು ತೊಂದಿರ್ಬೋದು. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಮುಂಬೈಯಿಂದ ಬೆಂಗಳೂರು ಟ್ರೈನ್ ಹೋಗಿದ್ದೀರಿ. ಸೊ ನೀವು ಮುಂಬೈನಾಗೆ ನಿಮ್ಮ ಸೀಟ್ ನಂಬರ್ ಸಿಕ್ಕಿದ್ದು 75. ನೀವೇನು ಮಾಡ್ತೀರಿ ಲಾಸ್ಟ್ ಹತ್ಕೋತೀರಿ. ಸೊ ಬೆಂಗಳೂರು ಬಂದ ತಕ್ಷಣ ನೀವೇ ಫಸ್ಟ್ ಇರ್ತೀರಿ, ಹೌದು? ಯಾಕಂದ್ರೆ ನೀವು ಡೋರ್ ಸೈಡೇ ಇರ್ತೀರಿ, ಡೋರ್ ನಿಯರ್ ಇರ್ತೀರಿ. ಸೊ ಅದಕ್ಕೆ ಲಾಸ್ಟ್ ನೀವೇ ಫಸ್ಟ್ ಇರೋದು ನೀವೇ. Is it clear? So last in, first one. That is leave. Okay. So then here takes place what is this topic. So it is also called as leaf, last in, first one. So whatever you have to here to insertion deletions takes place. Here two operations will be there, that is insertion and deletions. So insertion means what? Whatever you have to add the element, right? Whatever you have to add the element, you have to add the element in top end only, not middle, not bottoms, right? If you want to add some element, right? If you want to add some data, right? Example also it show on that day, that is Saturday, right? Clearly explain that is how the insertion will done, how the deletion will done, right? Definition of stack, right? Everything we will study. Okay, plates, right? So if you want to add some data, means you have to add top end only, not for middle, not for bottoms, right? For example, here you can take great example here. So A, B, C, D, E, F, G, right? Up to G plates are present in the stack, right? So you have to add one more stack, right? H stacks, H plane. You want to add, here you have to add the in top end only. You have to add the elements in upper side only, not for middle, not for bottoms. Right? Whatever the element you have to store, you have to store this upper side only, top end only, not middle, not bottoms. Same thing here, deletions. If you want to delete this E element, right? If you want to delete this E element, so what we have to do? We have to remove first this H element, then G element, then F element, then you have to remove this E element. Right? Unless and until if you are not removing these elements, it's highly impossible to delete the element in your stacks. Keep in mind. Okay? If you are not getting these three plates, if you are not getting these three elements in your stacks, it's not possible to delete this E element in your stack. Is it clear? So like this, insertion and deletions will be done in this type. Okay. So here, whatever you can, deletion means you have to remove the deletions. Okay? You have to remove the upper plate. You have to remove the books or plate, anything or element. First, we have to remove the upper side only. Okay. So how the operations will done? So if you want to add some element, right? If you want to add some element, first we have to check it the stack whether is full or not or exceed value. Right? If you want to add, for example, our stack capacity is only for 5, right? Right? This is a different example, this is a different example. Okay. So our stack capacity is only for 5 here. First, we have to check it whether the stack is empty or full or exceed value. Right? First, we have to check it out. So first, we have to check ಮಾಡ್ಕೋಬೇಕು ನನ್ನ stack full ಅದನಾ ಅಥವಾ half ಅದನಾ ಅಥವಾ exceed value reach agada. Okay? So here our stack is full. There is no need to add extra element. Right? It's not possible to add extra element in this stack because our stack is full here. Right? So it's highly impossible to add some element in top end. Why? Because our stack is full. Our stack capacity is 5. So A, B, C, D, E stack is full. So highly impossible to add one more element in upper side, top end side. Okay. So next we have to check one more example. So same thing here. Our stack capacity is 5, but here only 3 elements are present in the stack. Whatever you have to add the element, so first you have to check it whether the stack is empty or full or exceed value. Exceed means destination's value reach. Right? That should be keep it in mind. Okay. So here our stack capacity is 5, but here only 3 elements are present in the stacks. Yes, of course we can add the 2 element in top end only, not for bottoms, not for middle. Right? You have to add the element in top end. Of course, I am adding here 2 elements because our stack is not full here. Our stack is not reached the exceed value, and also our stack is not empty because 3 elements are present in the stacks. Right? So here we can add the 2 element in top end only. Right. Now we will reach the exceed value. Right? Now it's not possible to add the element. Okay. Fine. Now one more example, that is here. Same. First we have to check it whether the stack is empty or full or exceed value. Right? In third example I am showing you. So in this first example here, it's not possible to add the element, right? Because it's reached the exceed value. But here we will add these two elements in the stacks because our stack is not exceed the reach value. So these two are empty. That's why we will add the some element in top end only, not for middle, not for bottoms. But third example here, all the stack is empty. Right? Same thing, capacity is same 5. Right? Here, stack is empty. That means you can add up to 5 elements. Same obviously here. A, B, C, D, E. Clear? Right? So here our stack is empty. Now we are adding the element in top and only. A top B, B top C, C top D, D top E. Is it clear? So don't be confusions. Huh? So A map B D, B map C D, C map D, D map E. Our stack is reach the exceed value. Stack is reach the exceed value. Stack is reach the exceed value or stack is reach it. Right? Here not possible to add element. So where we are adding the elements in top end only. Okay, fine. Don't be confused. This is very important. This one I am telling you once again briefly. Right? In last class we are explained each and everything in examples. Right? In practical shows. I have taken some books. Right? On that day. Right? I am adding the some books where I am adding the elements in top end only, not for bottoms, not for middles. Right? I am showing you with practically on that day, Saturday. Right? So I am telling here. Right? So insertion will be completed. Now deletions. How to delete the element means here. So I want to delete. See, I want to delete this C element in the steps. So what we have to do? So first we have to remove this E element. That means we have to delete this E element. Then we have to delete this D element. That means you have to remove this D element is also. Then you have to remove this C element. Right? Unless if you are not deleting these two elements in upper side means it's not possible to directly delete this C element. You cannot delete this directly C element because our definition works is top end only. Insertion and deletion takes place at one end, that is top end. Right? This should be keep it in your mind. Whatever you have to insert in top end only. Whatever you have to read the data, you have to delete top end only. Right? First we have to delete this one. Next we can delete this one. Next we can delete this one. Okay, this is the deletion operations. Right? So then here only 3 elements are present in the stacks. So I want to delete this 3 element. Sir, every mode I 3 rows are sir. No, highly possible. First we have to remove this C element. First we have to delete this top element. Then only we can come to this D element. unless and until you are not deleting this top element, you cannot remove or you cannot delete this key element, because the definition what says insertion and deletion takes place at top end only. If you want to insert means you can insert the value in top end only. If you want to delete the elements, first you can delete the top end only. Right? If you want to add the insertions means you can add the element in top end only, not for middle, not for bottoms. Same thing here, if you want to delete the element means you can delete element in top end only. You cannot delete directly this B element. Right? First you have to delete this element, then afterwards you have to delete this B element. Is it clear? Fine. So then is empty is null. Right? Third and fourth operations. Is empty means what? Whether the stack is empty or not. First we have to check the conditions. Right? Whether the stack is empty or not. If it is empty means you can add the element. Is empty or not. Right? First condition check stack empty adana ಅಥವಾ ಇಲ್ಲ ಅಥವಾ exit value reach agada. Right? Is null means 0. Is null means 0. That means our stack is not full. Right? Our stack is 0. Stack is 0 position. Now we can add the element. Clear? Fine. So same thing Q also. Right? We will study afterwards. So here in the last class I told you why I am telling this briefly again. This is very important, stack and queue. Right? That's why I am repeating second time also. Right? On that day I will explain each and everything, but today I will briefly explain each and everything, whatever the concept is there in your stacks. Right? But one thing you can keep it in mind: insertion and deletion takes place at one end. Insertion and deletion takes place one end. Okay. That will be this main major point. Okay. So on that day, I told people algorithm we discussed in this class. So today come to this is algorithm for push and algorithm for pop. Same thing. Whatever we are studying in this stack and whatever we are studying this stack, that is insertion and deletion is empty, is null. So that will be write the algorithm part. So here study ಮಾಡಿಬಿಡಿ ನಾವು ಸ್ಟ್ಯಾಕ್ ಒಳಗ ಸ್ಟ್ಯಾಕ್ ಎಂಟಿ ಅದನ್ನ ಅಥವಾ ಫುಲ್ ಅದನ್ನ ಅಥವಾ ನಲ್ ಅದನ್ನ, ರೈಟ್? ಸೊ ಅದನ್ನೇ ನಾವು algorithm ಒಳಗೆ we have to write it. Right? What I am saying, first we have to check the whether condition is overflow or underflow. Overflow means what? Our capacity is only 5. So if you want to add one more element, that means what happens? Overflow. Right? Our stack capacity is only at 5 elements. Right? If you are adding 6th element means what will happen? The stack will be overflow. So what is the meaning of underflow means? Top minus 1. Top minus 1, that is n minus 1. Number of elements minus 1. Top is equals to top minus 1. Is it clear? Top is equals to top minus 1. So same thing here. Underflow means the value, the element which is not present in the stacks. That means our stack is empty. Right? That is our conditions, underflow conditions. That means there is no element are present in the stacks. The stack will not reach the exceed value. Right? Underflow means empty. The stack is empty. Okay? Underflow conditions. Right? Fine. So then here, push algorithms, obviously stack, top, size. So size is what? So stack like quantity, we have to add the element in top end element. Size, the capacity of stacks, that is 5, 10, whatever you are mentioning, that is. Right? Items means which item you are entering the stacks, which item we are inserting the stacks. Clear? Same. If top is equal to n minus 1, in the top another n minus 1, Then check overflow conditions. Right? We are going to overflow conditions now. Check whether the stack is empty or full or exceed value. Right? So you will condition check stack in position empty ಅಥವಾ exceed value reach ಆಗೈತನ ಅಥವಾ null ಅದನ ಅಥವಾ underflow condition ಆಗೈತನ. Right? Empty ಇತ್ತಂದ್ರೆ ಎಷ್ಟು empty ಅದಾವ, how many elements we are inserting in the stacks, 2 3 4. Right? Null means zero element are present in the stacks. That will be underflow conditions. Top plus 1. Right? Okay. Fine. Okay. Fine. So print stack is full. Whether the stack is exceed means obviously in print ಮಾಡಬೇಕು ನೀವು ನಮ್ಮದು stack full ಅಲ್ಲ. Right? We are not inserting any value, we are not inserting any element in the stacks because our stack is full. If I am inserting some element means the stack will be overflow. That was the class we are. Right? First we check top is equals to n minus 1, then print stack is full. Even to print manageri stack is full. Stack is full means what? You have reached exceed value. That is our stack capacity is, for example, I am taking this one. So you can mention how many you are inserting the elements. You can mention it. Right? So I am taking this one 5. So this 5 is a destination point. Right? In the stacks, 5 elements are present in the stack means we will reach the destinations. Right? Again, if you want to add one more element means what will happen on our stacks? Overflow condition. Is it clear? So end of it, step 2, top is equals to top plus 1. Then step top is equals to item. So increment the top. Right? For example, your stack is full only 3 elements. Your stack is full only 3 elements. So 2 elements are present. Top plus 1. Top plus 7 you add one more. That is so A, B, C element. Right? Top plus 1. Top plus 1. D. Again top plus 1. E. So this is the exit value. Stack is equals to top item. We are adding the item, inserting the item into the stacks, inserting the item. Right? So the reader stop. Or algorithm will stop here. Here. Same thing here. Algorithm for pop. Pop. Say stack top items. Pop means we are deletion operations, deleting the elements from the stacks. Right? Deleting the elements from the stacks. So first we have to check whether condition is underflow or not. ಏನು ಮಾಡ್ತೀವಿ ನಾವು ಫಸ್ಟ್ ಓವರ್ಫ್ಲೋ ನೋಡ್ತೀವಿ ಪುಷ್ ಒಳಗೆ ಅಂದ್ರೆ ಏನು ನಾವು ಪುಷ್ ಮಾಡಬಹುದೇನು ಪುಷ್ ಬಟ್ ವಾಟ್ ಪುಷ್ ಮಾಡಬಹುದೇನು ಪುಷ್ ಮಾಡಿ ಏನಾಗ್ತದ ಓವರ್ಫ್ಲೋ ಆಗ್ತದೆ ಏನಾಗ್ತದ ಬಟ್ ಇಲ್ಲಿ ಅಂಡರ್ಫ್ಲೋ ಕಂಡೀಷನ್ಸ್ ಸ್ಟ್ಯಾಕ್ ಎಂಟಿ ಅದನ್ನ ಇಲ್ಲ ಫಸ್ಟ್ ವಿ ಕ್ಯಾನ್ ಚೆಕ್ ದ ಅಂಡರ್ಫ್ಲೋ ಕಂಡೀಷನ್ಸ್ ಅಂದ್ರೆ ಸ್ಟ್ಯಾಕ್ ಎಂಟಿ ಅದನ್ನ ಇಲ್ಲ ಟಾಪ್ ಈಸ್ ಈಕ್ವಲ್ಸ್ ಟು ನಲ್ ರೈಟ್ ಟಾಪ್ ಏನಾದ್ರೆ ನಲ್ ಅದು 0 ಅದು then print stack is empty null is equal to 0 0 element are present in the stacks, right? Right? This is null value, so there is no element present in the stacks, right? Underflow conditions, top minus 1 sorry top plus 1 okay. Top plus 1 means we can add the element plus 1 plus 1 plus 1, right? Because it is a null, zero element are present in the stacks. Now we can add the elements. Then print emerging now, and of course our stack is empty because no element are present in the stacks, right? There is no element are present in the stacks, right? Exit, end of if, right? Then item is equals to stack which is equals to top, stack which is equals to top. So top is equals to top minus 1. Then return. Clear? So after that you can add the element. Clear? Fine. Okay. So then in stacks, some of the applications are there. So what are the applications mean? I am reading here. Conversion of decimal number into the binary. So these are the applications to solve tower of honey methods. Tower honey methods. I hope next topics it will be there. Tower honey method theory. So if it is there means it is compulsory questions for your aspirate question paper pattern. If it is there 5, if it is there 7 means this tower honey method will be compulsory. Okay, tower honey methods. So expressions, evaluations of syntax. Okay, expressions, evaluations and syntax parsing. Then conversion of infix expression into the prefix, right? Conversion of infix expression into the prefix, postfix. Conversion method, infix, prefix, and then postfix. Let me study what is the meaning of infix, prefix, postfix. One by one, let me explain. Let us uh, rearranging the elements, right? Rearranging the railroad cars. Okay. Fix all. Stock plan problem. Runtime memory management. Okay. Stack queue. These two very important, right? So I told you now what is the meaning of infix, prefix, and postfix. Infix, prefix, postfix. Right. So what is the meaning of infix? If an operator is in between the two operands, if an operator is in between two operands, prefix. I'll give you example. Don't worry. Prefix. If an operator processes two operands, prefix. If an operator proceeds two operands it is called prefix. Prefix expression. Prefix, postfix, infix expressions. So what is the meaning of postfix? If an operators follow the two operands, if an operators follow the two operands, it is called postfix expressions. So here, example, infix A plus B, where A and B are the operators. A plus B. Here, A and B are two operands plus is operators. Right? If an operator is in between two operands, this is one operand, this is one operand. So operators, which one is operators? This is the operators. Here A and B are the two operands. So plus is an operators. Prefix, if an operators proceed two operands, if it is called prefix. Prefix means if an operator, listen carefully, if an operators proceed two operands. Prefix means these operators present before only after the operands. Right? If an operators proceed two operands, it is called prefix expressions. So prefix means predefined operators. So first we will define the operators, then afterwards we will define the operands. Prefix means we have to fix the operators before only, after that we have to write the operands afterwards. Right? Prefix ಮಾಡ್ಬೋದು. ಮುಂಚೆನ ಫಿಕ್ಸ್ ಮಾಡಿದ್ರೆ ಆಪರೇಟರ್ಸ್ ಆಮೇಲೆ ನಾವು ಏನು ಮಾಡಿದ್ರೆ ಆಪರೇಟರ್ಸ್ ಅನ್ನು ಬರೆಯೋದು. See here. I am writing prefix operators, after that I am writing these two operators. Is it clear? Right. Same thing here. Postfix, if an operands follow the two operands, it is called postfix. Post means what? We have to follow the operands. That is anything but what? A, B, plus. Postfix. So we have to post the operators after the operands. Right? We have to post these operators after the operands. Operands are now operators in the post ಮಾಡ್ತೀವಿ. ಅರ್ಥ ಆಯ್ತ್ರಿ? Operands ಆದ ನಂತರ operators ಅನ್ನು ನಾವು ಇಲ್ಲಿ ಪೋಸ್ಟ್ ಮಾಡ್ತೀವಿ. Okay? Is it clear everything? So what is the meaning of infix? What is the meaning of prefix? What is the meaning of postfix? Is it clear everything? So infix is equal to what? If an operator is in between the two operands. If an operator is in between the two operands. So two operands present in the operators, in between the operators. Right? In between the operators, left and right side are present in the operands. Okay. So same thing prefix. If an operator proceed to operands, it is called prefix expressions. Prefix means what? We have to predefine expressions, right? Predefined operators. First we will define the operators, then after that we will define the operands. So same thing here. First we will defining the operators here. First we will defining these operators. After that we will defining the operands. Right? This is called prefix. So same thing postfix. First we will define the operands. After that we will define the operators. First we will define the operands. That is A and B. These two are the operands. After that we will define the this operators. Clear? Fine. So if an operators follow the two operands. If an operators follow the two operands, it is called postfix expression. You can get to know postfix expression in the now period. Is it clear? So everything is done. So one more time stack expression is done. Algorithm is done. Application is also done. Right? Everything is done. So now tomorrow we will study that is queues. So that is queue. How it will work in queues in data structure, right? The definition of queue. Okay. So everything we will study in tomorrow class. Okay. I hope all of you understand the today concept, right? Why I am repeating this stack one more times. So this is very important. So that's why I am repeating these stacks two times with an examples, with a practical also. Right? On Saturday I will show the practical also. How we are putting the elements, how we are inserting the elements, right? So where we are inserting the elements, it is top end only. Right? We are inserting the elements in top end only. So not for bottoms, not for middle. So if you want to insert in some element means you have to insert the element in top end only. So same thing, if you want to delete the elements means first we have to delete the top element only, right? So if you want to delete particular elements, right, means first, so if it is there in top means directly you can delete, or else if it is there in middle place, the element will present in middle place means first you have to delete the top end elements. So whatever the present in the stacks, whatever the elements are present in the stacks, first we have to delete the top end elements, then afterwards we have to delete the particular element where we can where we are mentioning in the deletions. So where which we are which element we are mentioning, the deletions will be done. So first we have to delete the elements, top end elements. Okay. So same thing here, algorithm is also done. So first we will check push element means we have to pushing the elements. Where we are pushing the elements? In top end only. Right? In top end only we are pushing the elements. Same thing pop means what? Pop means deleting. So where you are deleting the elements? In pop end only, in top end only. Right? So first we can check the overflow conditions and then underflow conditions. Right? First we will check whether the stack is empty or not, or stack is exceed the reach or not, exceed the element of reach or not. Right? First we can check it out whether the stack is full or not. If it is full means no need to add the elements. If you are adding means if you are pushing some element means what will happen stacks? Overflow. Okay, same thing underflow conditions, right? So keep it in mind. So everything I will discuss. So tomorrow class we will discuss that is stacks. Okay. So if you are not understanding means once you go through the video, try to understand the concept. Okay. So thank you very much.